Hi everyone, my name is Ana Sofia Reyes Garcia and I'm a PhD candidate at the Optical Communication Research Institute in la Universidad Autónoma de San Luis Potosí. In this video, we're going to discuss the work titled Synthesis of Silver Nanoparticles Using Nanocellulose for the Application in Dental Prostheses. In the last years, silver nanoparticles have acquired great relevance thanks to their antibacterial properties, biocompatibility, and low production costs. These characteristics have favored their application in various medical areas and more recently in dentistry. Nanocellulose is a natural polybiopolymer that stands out for its high mechanical strength, biocompatibility, and biodegradability. Its incorporation in composite materials significantly improves its properties, which make it a promising reinforcement for a dental prosthesis. The aim of this work is to combine nanocellulose and silver nanoparticles in order to develop materials with improved mechanical strength and antibacterial properties. This approach is particularly relevant because dental prostheses are in continuous contact with the oral cavity, where they can be colonized by microorganisms such as Candida albicans, a fungus that is difficult to eradicate. And the addition of silver can help prevent infections, prolong the durability of the material, and improve the quality of life of patients. The synthesis of nanoparticles was carried out using a green method with the purpose of minimizing the use of toxic reagents. Nanocellulose suspensions was used as a stabilizing and partially reducing agent, and an aqueous solution of silver nitrate was prepared as a precursor. Both solutions were mixed under controlled conditions of temperature and time, favoring the formation of the nanoparticles. This product was subject to centrifugations because we need to separate the nanoparticles and eliminate impurities. Finally, an anti-evacuation treatment, we can talk about this because we have a patent pending, and was applying to guarantee the stability and functionality of the nanoparticles. The synthesis nanoparticles were characterized by, first, for Raman spectroscopy, which allowed the identification of characteristic vibrations of the nanocellulose, and change associated with this interaction with the nanoparticles. And the second is the scanning electron microscope, which allowed the observation of morphology and distribution of the nanoparticles. Subsequently, the nanoparticles were incorporated into place of PMMA, polymethyl methacrylate. This is a material widely used in dental prostheses. These plates were prepared with different concentrations on nanoparticles in order to evaluate in later stage their mechanical properties, in particular flexure strength and hardness. As results, the Raman spectrum of nanocellulose showed characteristics peaks, which are associated with characteristic vibrations of the polymeric matrix and its interactions with the nanoparticles, confirming their correct formation. And the important peaks are this 375, the next 1093, and the other one 1375. And we have the nanoparticles synthesized in the presence of nanocellulose, who presents peaks at 235, 786, and 1394. Same analysis revealed that the nanocellulose prevent agglomerations of the nanoparticles, achieving homogeneous distributions at the nanometer scale. We can see the fibers of the nanocellulose and we can see the nanoparticles in this part. PMMA plates were prepared with nanoparticles using nanocellulose in different concentrations, and these were ready for future mechanical testings. In conclusion, silver nanoparticles were synthesized through a sustainable process using nanocellulose as a stabilizing and partially reducing agent. Raman spectroscopy and SEM analysis confirmed the stable and homogeneous formation of nanoparticles. Nanocellulose played a key role in controlling the growth and dispersion of the nanoparticles, and incorporations of nanoparticles into PMMA constitutes a promising strategy to improve the mechanical strength and the antibacterial properties of dental prostheses. And this work opens the door to further studies in which the mechanical and biological performance of prostheses reinforced with nanoparticles will be evaluated in order to offer safer, more durable, and biocompatibility solutions for our patients. And this project demonstrates that the combination of nanocellulose and the nanoparticles is a promising strategy for the development of a new generation dental prosthesis with a positive impact on both materials strength and patient health. Thank you very much for your attention.